Okay everyone, welcome back to part 3. So in part 2, just as a very quick reminder, we plotted the whole year, we then zoomed in on October, and then we plotted just the storm and we extracted the kind of maximum water levels, maximum surge levels, and then finally the maximum tidal levels. Okay, now what we're going to do is actually look at meteorological data to try and work out why there was this such big surge. So we're going to actually set up a control 3. And what we're going to do is use data from ERA 5, which is a meteorological reanalysis. It's kind of like a model, but it sucks in real data and it produces this kind of global database of temperature, winds, pressure, rainfall. It's very, very impressive. Now, I've put the link in the slides, but if you go to this website, you can read a bit more about the ERA 5 data here. And if you go to data download, now you won't have a Copernicus account. So you'll probably need to click up here and log in. First of all, you have to register for an account. It should be all free, but you have to register. Now, it's been a while since I registered, so I can't remember how long it takes. But hopefully it'll only take a couple of minutes. Sometimes you have to wait an hour, but I'm hoping in this case it'll be quite quick. So we're going to go through and tick the reanalysis. Now it's already got everything ticked because I did this early in the day while I was practicing. You click the 10 meter winds, U and V, and mean sea level pressure. That's atmospheric pressure. And that's the two things we're interested in. In week 3, you'll see the storm surges caused by low pressure and strong winds. By default, you're always interested in its winds 10 meters above the surface. Now, if you zoom down, pick 2012, October, the 30th day, and we're just going to look at one time, which is hour 1. Now, rather than clicking the whole region, we're going to click a sub-region, and we're going to go from 100 degrees west to 50 degrees west. We're going to go from 10 degrees north to 60 degrees north. Click on NetCDF and then submit your form. Now I did this one early in the day, so we can delete that one. So you'll just get one up. It might take a minute or two before you can download it. But if you click on download here, that will go into my downloads folders. So we can go into Practical1, data. I'm going to go into my downloads folder. Now, it comes with a horrendously long name, so I'm just going to rename that as sandy.nc. Now you can't pull this into a text editor because it's not a text file. It will be huge and it just won't make any sense. It's a NetCDF file, which is a really useful file for looking at kind of storing matrix type data. Now, if for any reason you're struggling to download that, if you go back into Blackboard, into that data download, you should be able to see there's a Sandy NetCDF file there as well. But please don't use that. I'd rather that you use the ones that you downloaded because it's quite satisfying. But for those of you who have any problems, you can't register, that's that there. Okay, so what we're going to do is set up this third script. As always, set up your headers. I typically like to just cut and paste and then change it. So this M file loads in ERA 5 data and plots atmospheric pressure and wind speeds for Hurricane Sandy. Okay, so now let's load in the data. So again, we'll do a block. Step 1 is load in data. And as always, I set up the file name separately. So the file name is going to be data and sandy.netcdf. Now with netcdf, you can't use the load function. You have to use a special netcdf function. And there's a function called netncdisplay. And you give it the file in. Now let's run this. Now when you run it, it tells you the formats of the file. So it tells you the date it was formatted, and here are the variables. So there's a variable of longitude, which is 207 long, latitude 201, then there's time, there's only one time, there's U10, V10, and mean sea level pressure. So what we can do is, now that we've run that, I'm going to switch it off because I know what it's called, but now what we can do is use the, so let's go for long. Long is NC. We can use the NC read function. We need to specify the file name and then the property. So in this case, the first one I'm going to load in is the longitude. We can run that and you can see it's loaded it in. So it goes from -100 to -50, which is the region I specified. And you can see it's actually quite good resolution, every 0.25 degrees. So it's a global grid approximately every 25 kilometers. Now we're going to do the latitude, and we can bring that in. In fact, I'm going to bring the NC display back up just to remind me what the parameters are called. And then we are going to do pressure. I always try and name things short. This is going to be MSL if I remember rightly. Yep. And then U, the U component of wind is U10. And this is in meters per second. And then the V component of wind. Now, previously we've used kind of, in Control 2 we used kind of one-dimensional data. It's just a column of data, but here now we've got gridded data. So kind of longitude, latitude, and this is atmospheric pressure in hectopascals. Let's just double confirm that, but I'm pretty sure, yeah, it's air pressure in pascals. Not hectopascals, sorry, it's pascals, which is the force per unit area. Now, in order to plot this, I need a grid. So I'm going to have to set up create a grid, or else I'm not going to be able to plot this. But what's really nice is there's a function called mesh grid. And if I give it the lat and the long, and then I specify a y and an x, if I run this, you can see, I'm just going to switch off this NC display again, but now you can see it's set up an X and a Y for me. Let's have a look at those. So this is the longitude, which was varying from -150, and then this is the latitude, which I think varies from 60 to 10. Okay, now I can start to plot things, which is nice. But before I can plot things, I'm going to load in the coastline. So I'm actually going to nick the code from Control 1. I'm going to load in the MATLAB coastline. Remember, that's the coast lat and the coast long. Now I can plot things. Okay, so let's start simple. Let's plot the atmospheric pressure. Now, what I tend to do is I tend to just borrow code from somewhere else. Now, in this case, I'm not going to bother with a title, but what I'm going to do is we can come back to that in a minute, but it's going to be longitude in degrees, and it's going to be latitude in degrees. Okay, now what I'm going to do is use the P color function, and the P color function, again, you can use the help, or what's quite nice is you can go into the help menu up here and type P color, and it'll actually give you some examples, and it'll actually give you some scripts that you can kind of run this on. So P color, you just need a color, or you need an X, Y, and a kind of Z matrices, and it will give you examples of how this works. Okay, so what we need is we give it the x, we give it the y, and then we give it the p. But I'm going to divide p by 100 to get it into millibars, from pascals to millibars, because most weather charts use millibars. So let's run that. And here you can see the grid. Now, it plots it as a grid, so to get rid of the grid, I'm just going to use the shading interp function. So there you can see is the low pressure, but it doesn't make a lot of sense because I haven't plotted on land. So let's go back to control 1. We can borrow this land file now, and then we can plot that. So there you can see it's plotted that block, but I don't want to plot the whole world. So I'm going to say axis is equal, and that just means that both the x and the y will be the kind of same length, and then I can use the axis function like I've done earlier. In fact, I could probably borrow this here, cut and paste that across, although here I think I went from 10 to 60, and I went from minus 100 to 50. And let's run that. Okay, there you can see the pressure, and what's really nice is you can see that the storm is low pressure just near Manhattan. And that low pressure is going to generate a storm surge, and we'll see the winds a bit later on. Now what I'm going to do is I'm going to add a color bar, just using the color bar function. So there you can see, and I'm just going to round it off nicely, and you can use that using the C axis. Here you just need 2 colors, so I'm going to go from 960 to 130. And there we go. Okay, so the next thing we're going to do then is plot wind. And again, I'm just going to kind of borrow this code here because we can just kind of edit it out. Because I'm going to need some similar sort of things. So this is going to be number 5. It's really good practice. People get lazy with commenting, but I think it's really good practice to keep your keep track. Okay, now we can actually use a function called quiver, and this has 4 inputs, an x and a y. In fact, you can see the inputs coming here. Now we need a u and a v. And here, I'm going to just make them red, so I can put an R at the end. Here you can see the vectors, but it's quite hard to work out what's going on because they're so small. I mean, you can zoom in, and I think I've made a mistake up here. I knew I'd made a mistake because they didn't look quite right. They should be a circle. So here we can zoom in, and we can see that you can see the storm there, and you can see particularly the onshore winds pushing water towards Manhattan, which is generating that very, very big surge. Here, if we had a tide gauge site here, we'd probably see a negative surge because of the offshore winds, and we'll see that in particular in week 3. I'll discuss this in a lot of depth. But this figure doesn't look particularly nice because there's too many vectors. So what we could do is actually plot less vectors. And what I'll do is, again, just so you can see, I'll plot wind vector, plot fewer wind vectors. Now here we're plotting all of x, all of y, all of u, and all of v. But what we could do is actually just plot parts. So I'm going to go from 1 at intervals of 5 to the end. That's the rows. I need to do the same for the columns, 1 to 5 to the end. And I need to do this for x, y, u, and v. And we can run that, and what this will now do is just plot every 5th vector instead of every one. And if you can compare them, you can see that plotting fewer vectors is much more clearer. And what I'm going to also do is just scale the vectors. You can add in another thing here where I can increase them by 2. And now you can really clearly see the onshore winds there. We zoom in, onshore winds in Manhattan, which are generating that very big surge. Now what would be really nice is to combine the plots together. So actually we could plot both. We could plot atmospheric pressure and wind vectors together. Now I'm going to go back up to my pressure thing and just pick the P color code. Oh, I need the shading interp as well. And I'm going to drop it in here. And now I've plotted them together. Now there's lots and lots of different color maps. And I think you can, I can't remember how to do this because I haven't done this for so long, but I think you can click on the color map here, and there's lots of different maps to choose from. I can't actually remember how to do that. Tools. Somewhere you can do it from the command window, but I'll show you how I typically do it. You can actually define a color map using the color map function. Now that's a default one, but I'm going to go for jet, which is another one. And there you can see jet. So this is a really nice one. So you can see it's the low pressure and those strong onshore winds that are generating the storm surge. Okay, now here I have atmospheric pressure in the background, but actually it might be quite nice to plot wind speed in the background. So let's do that. Just check my numbering. I'm a bit pernickety. Let's plot wind speed instead. Now with wind speed, we don't have the wind speed, we just have U and V. So we need to convert that into a wind speed. So the first thing we need to do is calculate the wind speed. Now when you have two vectors, one going eastwards, one going up, you can use Pythagoras' rule. So we can say the speed is the square root, and it's the square root of u squared plus v squared. You use this dot to avoid MATLAB matrices. Okay, and now we can, so I'll just run that and we generate this SP. So this is now speed. And here, I can copy and paste this, but instead of plotting P, I'm going to plot speed, and I'll need to change my C-axis. I think I'll go from 0 to 25 meters per second squared. And this is now wind speed. So you can see really strong winds there pushing water onto the coast. And you can see the winds get weaker and weaker. They're not so obvious on land. Now rather than jet, I can use hot. But really I want the darker reds to be the stronger speeds. So what I can do is I can actually use the flip up function to just flip hot. And now it should put the darker colours. Have I spelt that correctly? Flip. Flip UD. And now you can see there, it's looking really nice with the really strong winds. You can see how the storm changes as it goes over land. Okay, and then just the final two things we'll do is, what's really nice is you can actually plot this in 3 dimensions rather than 2 dimensions. So let's start with the pressure. Let's get our numbering right. Plot atmospheric pressure in 3D. So rather than using the P color function here, I can actually use surf. And we can run that. And to make this nicer, I'm actually going to get rid of the coastal land. Now, if you hover your mouse over here, there is a 3D rotate, and there you can kind of see the wind fields. I'm just going to take off the axis equal, just to not restrict it, and let's put the color map as being jet, which I think looks a bit nicer. So again, so notice how I just always copy and paste if I've done it before. So let's click on that 3D view again, and now you can really clearly see the low pressure of the storm. You can see, yeah, really nice and kind of symmetrical. And down the bottom here, you can see 2 numbers, -50. That's the kind of altitude. So if you want, you can actually do that yourself using the view function. And for example, I can never remember exactly what these numbers are, but one kind of changes the tilt, one changes the angle, but there you can see I've kind of viewed it from a certain angle. Okay, and we can do exactly the same with the wind speed. So let's do the wind speed. So again, plot wind speed in 3D. Now I'm going to use the same hot color map because it's really nice. Here I'm going to replace that with speed, and the C-axis I need to go from 0 to 25. Now that's the speed, or I can do it in the same jet like I did with pressure. And there you can see the really strong wind speeds were very near Manhattan. You can see that this one is much less symmetrical, and the higher wind speeds tend to be overland, so it's not as nice as the pressure one. Okay, and then as a final thing, just so that I don't forget, I'm going to set up another variable, and you'll see in all the other practicals I'm going to do this at the very beginning. I'm going to call this readme, but rather than readme, I'm going to call it a readme, and I'm going to put it right at the beginning. And the reason why I put it A is so that it shows up first in my folder. So if I come back to this project and I can't remember it, it's the first thing. I can click on it and find out. So this M file lists the scripts for Practical1. So there's going to be three scripts. A list of M files. Now the first M file is control1, but I'm going to use the word control, and I'll show you why I do that in a minute. And I'm just going to cut and paste what that does. So this plots the tide gauge location. So I'm going to copy that there. Then I'm going to do the same with control2, and then I'm going to do the same with control3. And I can just copy this in. So this is really nice. I can just very quickly go to one place and just remind myself if I've forgotten what each of these things do. So it's a really good practice to do that. Now what's really nice is if I close down the project, I come to it, I can open this, and because I put the open there, I can just run the script, and you can see it will open those in the correct order for me. Okay, so that's the end of Practical1. I hope you've enjoyed it. I'm sure it's intimidating for some of you who've never used MATLAB, but with a really little bit of practice, you can actually get good quite quickly, and you can hopefully see the real power that we've been able to produce the most amazing kind of plots here using relatively simple code. Okay, thank you.